Hello everyone, welcome to another lecture of C programming. In today's lecture, we're going to talk about data types and constants. In the last representation, we have discussed about variables. How can you declare a variable? What is the definition of a variable and how can you initialize it? Also, when you declare a variable, you knew about that there are two properties. Basically, you can understand while declaring a variable. First one is the name of the variable, another one is the type of the variable. And there, the type of the variable is the data type. That means which kind of data you want to store inside a variable. Either you can store a numeric data or a character data. So let's discuss about first data type. Okay, so to understand a data type, we have to first understand the basic thing. How much a variable can store a data? What is the size of data? A range of data. You knew about a computer only understand a binary number, that is 0 or 1. These are either the states of switches. If switch is on, that is 1. If switch is off, that is 0. Okay, the smallest unit of memory is bit, basically 8 bit. So when you store a number into a computer, either you have to store into in this binary form. Okay, it may be 8 bit, maybe 16 bit, maybe 32 bits or 64 bits. So here, if you take 1 byte data, that means you have to take a storage 8 bit. So 1 byte is equivalent to 8 bit, and every single bit is either 0 or either 1. So these are the different states of the 8-bit data. Suppose you want to store the number 5. 5 is a decimal number into a binary. Then you have to convert into binary. And the equivalent of binary of 5 is 101. So when you divide 5 by 2, it gives you a result as 2 and remainder is 1. So here again you 5. In this way you have to calculate the binary equivalent of 5. So if you want to store 5 into binary, then it will be 101. Okay, so a 5 here takes 3 bit 3 bit memory, basically as given by as taken by the data 5 decimal data. Same way, if you want to store a number in which all the bits are set. Okay, so suppose there is a number which is a binary number where all the bits are 1, all the 8 bits are 1. So equivalent binary form of this number. So here this is the size of the that binary number. Here 8 1. All the bit are 8 bits are 1. That is the maximum size of 1 byte binary number. And how can we calculate that range from this formula? That is from 0 to 2 to the power n minus 1. So the minimum number you can store a positive number or a non-negative number, actually that is 0 also. So that is 0. So here you put here 0 0 0 0, all the bits are 0. So here the minimum value is 0. And what about the maximum value? So maximum value is 2 to the power n minus of 1, where n is the number of bit. And here number of bit is 8, so the 2 to the power 8 minus 1 gives you 255. So 255 is a decimal number and the equivalent binary number of 255 is 11111 up to here. So the maximum value you can store into 1 byte is 255 if it is a unsigned number. Okay, so this is basically a size and range of a data. Suppose any data type, because a data type basically specifies the size of the memory, which kind of data you stores basically in that variable and how much memory basically it reserve into the computer. Suppose some data type which takes 1 byte, then the maximum positive value you can store in that variable using that data type which take 1 byte memory, that is 255. Okay, and also if you want to store in that variable which basically take 1 byte memory greater than 255, like 256, then it will store it as 0. Why? Because it works as a loop. Okay, So if you want to store higher data after 255, like 256, the it equivalence as 0. Okay, so you can not write 256 into that variable of that data type. Okay, so it equivalents to 0. It will not give you value 256. Why? Because the range of that data type is up to 255 if that data type has 1 byte memory. Okay, so you cannot write the data, exact data after their given range. So this is all about the range of the data and the size of the data. Now understand what is a data. What is a data type? A data type specifies the type of data that can stored in the variable. So what are the type of data? Either we have a numeric data or a character data. And depending upon a data type, we can understand that a variable can store the numeric data or a character data. So here there is a declaration int var1. Now you can see that int is a data type. Okay, so with the help of this declaration, so we can say that var1 can store integer data. Okay, so here int is a keyword which is used as a data type. So keywords are the reserved words. You cannot use the keyword as a name of a variable. Okay, so now let's take a look. What are the different types of data types? Data types are classified as a primitive data types, derived data types, and a user-defined data types. What is a primitive data types? Primitive data types are the basic data type, like numeric type or character type. So you have only know about two kind of data type: data that is a numeric or character type. So those are the primitive data types. So a numeric data, either a integer value or either a float value. So integer value is 3, -3, 4, 5. So these are the integer numeric type, and 3.45 -6.78. So these are the floating point numeric type. And here we have another type is character type. So if you want to store a single character, so you have to use a character type. And generally in C programming, we write any single character inside a single quotation. We don't have any primitive data types to write a sentence, to store a sentence in C programming. We can only store a single character, either it's A, B, C, or any symbol inside a single quotation. That is a character in C programming. So these are the primitive data types. So after primitive data types, we have a derived data types. So as name suggested here, derived data types. Derived data types are derived from primitive data types. And the example of derived data types are arrays, functions, pointers. So these are the derived data types. So with the help of primitive data types, we can make a derived data type. Okay. And also, we have different chapters for arrays, functions, and pointers, where we will discuss derived data types in detail. And after that, we have user-defined data types. What is the meaning of user-defined data types? So basically, in user-defined data type, we define the data type. Okay, so here we basically use a primitive data type. We can use a derived data type. Also, we can use other user-defined data types to define a user-defined data type, like structure, union. So these are the user-defined data type. Also, we have separate important chapters on structure and union in C programming, and we will discuss about user-defined data types there in those chapters in details. And now, understand the primitive data types. So, we have a primitive data type, that is a basic data type. For numeric type, we have int or float. Okay, for character type, we have char. So using int keyword, you can store integer value inside a variable. Okay, and using char keywords, you can store a character value, that character type inside a variable. And using float keyword, you can store a float value inside a variable. And here we have a void keyword. Okay, data type is void data type, and the void data type holds no value. Okay, so it basically used in different type of cases, like If you want to specify the return type of a function, that you can use y data type there. If you want to uh, specify the parameters of a function, that is argument of a function, if it takes no arguments, then you can use a y data type there. If you want to create a generic pointers, then you can use y data type there. Also, these chapters like pointers functions are different chapters in C programming. We will discuss there in detail. So don't worry about y data type. We will discuss y data type also in those chapters in details. Now, let's talk about kind of data type of integer. Okay, so in C programming we have a different kind of modifiers. So C can also supports two sign specifier and two size specifiers. Okay, so first two sign specifiers are sign and unsigned, and two size specifier are short and long. So what are these specifier? So basically, if you want to store a number into a computer memory, either those number is signed number or either a unsigned number. So when we write a number in a decimal, that is a 5, that is signed number. When you write a negative number, that is -5. So it is easy to write a number into decimal, but when you're going to write the number into a binaries, and it is quite difficult. Okay, so we have to use a different type of representation, like sign representation for negative numbers. Okay, so for that also we have a different kind of specifier. Okay, so if you want to only store a positive number, not a non-negative number, that is a zero from the that given range, so we can use unsigned keyword. Okay, and if you want to store positive numbers as well as negative numbers, we can use sign representation. So here int data type can be classified as short, int, and long. Okay, so what are these? Why these data types are classified further? Because if you want to store a short integer, like not a very big integer number, then you can use a short data type. Okay, and if you want to store a very long integer which range is greater than the range of int data type, then you can use a long keyword. So these things basically gives the efficiency of the memory. If you want to store smaller data type, integer data type, then you have to use a short keyword, that's short data type. It should be memory efficient. You do not waste your memory. Okay, so why we have to use a different kind of integer data type like short, int, long in C programming. And float further classified as float, double, long double, depending upon the size of the data. Okay, so size of the decimal data, that is a float kind of data, fractional data, sorry. Okay, so if we have a very large floating point numbers, we can use long double. If we have a smaller floating point numbers, we can use float number. Also, we have signed sort, unsigned sort, same as take a look on how the size is varies and also the range of a data type. Okay, so let's see here. So depending upon computer architecture, if it is a 32-bit computer architecture or 64-bit computer architecture, the memory size of some data type is different. Suppose if you have an integer data type, then it is 2 byte when we use a 32-bit computer architecture, and memory size is 4 byte when we use a 64-bit computer architecture. So why the range also varies. And same if it is a unsigned int, then the range value starts from 0 to 2 to the power n minus 1. Okay, so here, and also sorry, also for long int, if you have a 32-bit computer architecture, then memory size is 4 byte, and if it is a 64-bit computer architecture, then memory size is 8 byte. Also, you can see here for float, if you use any value, that is a 32-bit computer architecture or 64-bit, the size of float data type is 4 byte. That means the variable, okay, the variable stores data up to this range. Okay, so the maximum value that variable can store here
up to this. Okay, and the decimal precision range is up to 6 decimal precision places. That means 4.23678. Okay, so up to 6 decimal places you can store the value inside the float data type variable. Okay, and for double we have 8 byte. Depending upon any architecture you can use double as a 8 byte memory size, and for long double 10 bytes. You don't need to remember this whole range and the memory size of data type, but you have a basic idea about how basically what are the basic range of a data type. Suppose if you want to store a very large number, integer number, okay, so you there you should have to use a long int. Okay, and if suppose that number is very large and integer, then you can use unsigned long int. Same way, if you have a fractional number that is a floating point number and that number is very large, then you can use a long double. If you want to store a single character, then you use char data type. Okay, and there is no any primitive data type for storing a sentence in C programming. Okay, also let's we write some program to understand about constant, and also we can see there how the value changes if you overflow the range of the data type of a variable. Okay, so let's see. Here we're gonna write some data types and constants. Okay, so program related with data type and constants. We have to first write a header file h include stereo.h, and after that we're gonna write main function int main, and we just write some data types like integer, and here variable name is a, and after that we're gonna write a float data type, that is float b. Okay, so we're gonna put some floating point numbers inside float. After that you can take a character data type as char grade e. Okay, and here semicolon, and if you want to write anything as a single character, so you can write in single quotes. Okay, and after that sort a1 or sort integer, and then long int and double e3. Okay, for larger data type. After that we can write a long double for very large double floating point numbers. Okay, and here you can write as an unsigned int, and we're going to write the maximum value of unsigned int as here variable a5, that is 429496, and it's 725 sorry 95. Okay, so that is the exact number. And printf, we're going to print all the data as in this way. We're going to first print integer a, after that we're going to print b, then grade a1, a2, a3, a4 and a5. Okay, and also you can see that here a is equal to %d, and %d is a format specifier. Okay, and a is equal to %f. If you write a floating point numbers, so for floating point numbers you have to write a %f as a format specifier, and for a character data type you have to write %c. Same way, for a short integer you have to write %hi, and for long integer you have to write a %ld, and for floating point numbers you have to write %lf, and same way if you have a very large floating point numbers like long double, that you have to write %ld, and for unsigned int you have to only write %u. Okay, so also we will discuss about format specifier in detail in next lecture. Okay, so here you can see that if you want to add one value in unsigned int a5, that is what should be the next value. Okay, already I have discussed about the loop. The new value can update it as 0. Okay, so here we're gonna update the value of a5 as a5 plus 1, and now we can see that the new value is not the next number of unsigned int the value of a5, it is another number, like it is not 4294967296. Okay, so here let's talk about constant. If you write a variable, then you can change the value of variable anytime. Okay, so here I have updated the value of a1 as 99, the new value of a1, and also I have updated the value of a2 as 0. Okay, but what about constant? When you write a constant, the value of constants remains unchanged. You cannot update or change the value of constant in a C program. Also, how can we write a constant in our C program? So there are two ways. There are two ways to writing constants. First one is we can use a const. Okay, so const keyword. So here the constant keyword can be used as a specifies the constant. Okay, so for that we're gonna write as const, then after data type, then variable name, and after that we're gonna assign any value which we want to be constant. Here I'm gonna write const int num and 0, and again write const and float, and then pi 3.17. I'm gonna write the value. So these are the yeah, so in this way you can write a floating point numbers, sorry, constant value in a C programming, and the data will not change. Okay, and also we're gonna see that what happens when data is overflow, just like when we're gonna add the last one in unsigned int. Also another way is writing constant is like uh, macro. Okay, so here that is not right, it's WRIT, so sorry for the mistake. And so we're gonna use a hatch defined macro for writing constant. Okay, that is hatch defined max 10, and here the max is a macro. Okay, by default we cannot write a macro with a capital letter, but there is no any convention. It is a convention. Okay, but there is no strict rule you're gonna write a capital letter or a small letter. We're gonna write with a small letter also, that is new max, and here we're gonna print our constant value, and that is uh, first one is our using const keyword, another one is after using our macro. So there are two ways to writing constants in C programming. First one is using const keyword, another way is using macro. Okay, so here hatch define is a macro, and also I will discuss about macro in detail, so don't worry about that. For here, for constant I only introduce about hatch define macro. So if you write anything inside the name of a hatch define macro after that, so it will replace as it. So here hatch define macro, when you write a max, so max here behaves like a constant, and when you're gonna write a value of max anywhere in C programming, that will update as 10. Okay, so that's why we have taken max value of max as 10 here previously. And here also we have new max. Okay, sorry, new max, then write a new max as, and sorry, we're gonna write here backslash n. So also we have to print new max. Okay, so we have to just write %d because max is an integer there, so %d, and here also we have to write %d because here is the new max is also integer. You can write in small letter as well as uppercase letter, but the convenience is that we have to write in a capital letter. So we're gonna save this program and just run this C program. Okay, so just see the output. So here you can see that the value of a was 6556. Okay, 65546, that is an integer. The maximum range of integer is 2 to the power 32 minus 1, so that is okay. So here that value is also okay for floating point numbers here. And now the value of a5. Okay, so here you can see that the previous value of a5 was 429,496,7295, but the new value of a5 is 0. Why?
Thanks for watching, and if you like the video on C programming, so please do subscribe the channel, and also if you have any doubts you can write in our comment section. We will pleased to help you.